Hi.
Hi.
So we're here, where are we? Hi.
We're in beautiful Ferndale, Washington at my house.
So who are you?
I'm Tyler Baker. I'm the Chief Technology Officer at Foundries.io.
So CTO of the Foundries.io. So what's the latest with Foundries?
So we just launched a product called FoundriesFactory. It is a cloud infrastructure tool to allow you to customize your own embedded distribution, update it over the air, manage devices in the field, and deliver Docker apps securely to any registered devices.
So what's the main idea with Foundries.io and what's the latest business model?
Right, so users can sign up. They get a private space where they have source code which overlays our distribution, which is the Linux microPlatform. They can change the bootloader, they can change the kernel, they can change user space packages, or they can just leave it alone and work on the applications. They also get repositories to add containers, which will be built for ARM 64, x86, and then signed securely into our registry. And then we use the update framework to deliver them with Actualizer Lite to the platform.
So one of the challenges with IoT is that all these devices around in the world are not being updated.
Correct.
And you are providing the fix for that.
The FoundriesFactory, we like to think of it as like the Tesla-like experience, where you get these over-the-air updates, they add features, but really it's about stability, and it's about allowing the customers to be able to make changes themselves rather than dictating what they can change and what they can't. So yeah, we use OS tree and we secure it with the update framework. So it's an incremental update when you push builds down to the devices, and then the same is true with containers. They're incremental layers, and only the layers that need to get pulled.
So it's a challenge to keep security in IoT, and this is the solution, the best way to do it?
Well, so here's the thing. Security is a hard one to solve, right? There's no silver bullet, as they would say. What we believe in is the latest software is the most secure software. So how do we run the latest software? We need to give the tools to make that happen.
So right here you're showing some of the solution?
Yeah, so on this top one here, this is our output of our Actualizer Lite client, which is,
hold it right,
just go like that, there you go.
Yeah.
So it's refreshing for updates. There are no updates. Down here I made a quick change to the containers that's running. So this is our device under test here, or device that's registered, and clearly it's in X-kiosk mode. It's running a Docker app, which essentially is Chromium in a lockdown browser running X11, and it's showing our Foundries website. What I've done though is I've just pushed a change to change this to Charbax's YouTube website. So in a moment here, once the build's done, I can kind of show you here. Let's see if I can pull it up. It is building currently. So build 110 is running. We are just waiting for these things to finish so we can actually take a look at the log. So you see we are building AR64, ARM-HF, and ARM64. So what's great about this story is the same software for the operating system or the Docker app is going to be built from the same source code, but just configured for different architectures. So if you're running a deployment that has multiple architectures, you have a single source code base to audit for security vulnerabilities rather than having multiple. So you think that this is going to simplify the security story a little bit. So essentially all you have to do is just push into your Foundries Factory, which you can sign up for on our website. There's a $10 a month kind of personal subscription, which allows you to have up to 10 devices and 3 builds a day. And then our enterprise tier is unlimited devices and unlimited builds per day, and that's $5,000 a month. So oh yeah, go ahead. So
an IoT device maker can start to see if they can make all this work with their prototypes.
Yeah, and if
it's awesome, they can make millions of devices and just play fat fee.
Right, and I think that's the key to our business model is we don't have any per device charges. We don't want that. We think that can be towards the end of production when you start to scale out the number of devices, can be prohibitive. So we want to charge a flat fee that is somewhere in the range of a half of an engineer per year. That way the costs are kind of amortized over our entire customer base, and we can provide better tools and newer features and use all this feedback from customers using the Foundries Factories to provide better features and more cool upstream software.
And you're a little bit kind of like a spin out of Linaro, right?
That's correct, yeah.
And for example, you live right here, right next to Canada. Canada is just over there.
Yep.
And you have some, even though you're a startup, you already have some engineers a little bit around the world?
Yeah, so we have a whole bunch of engineers around the world, Brazil, France, UK, Los Angeles, Austin, Texas, Spain, We're actually looking to maybe grow a little bit in Brazil and all over the world. So yeah,
and you can grow depending on how many customers you get, right?
Yeah.
If you get lots of traction, you can hire engineers anywhere they want to live.
Absolutely,
and
and
they
that's
just
the
work
appeal.
over the internet,
We
right?
want the best engineer to work for Foundries, obviously, and so being able to hire anywhere in the world is a definite advantage.
And people can work from home
Absolutely.
and maybe meet eventually,
Yep.
but they don't have to.
Right, it's similar to Linaro in the sense that we have Linaro Connects and everybody gets together. We have sprints for a company. Now, we're not as big as Linaro, so it's only a handful of people at this point. But that's the idea.
Not yet.
Yeah, not yet, right? Maybe
Not
we'll
yet.
have a developer
It could be.
conference one day, yeah.
If the business model is just like perfectly architectured, right? If the design of the business model is exactly what the IoT industry needs, this could be huge.
I believe so, and I really want to see more people running upstream software because that's the key to security. It's hard to do it for various reasons, for certification, for stability, and we want to provide tooling to make that easier, right? And just to secure your software is already hard. And how do you provision it? How do you do the keys? How do you use hardware security modules? We want to kind of solve that already in our base platform, and then give you the tools that you pay for a subscription for to help you, manage these deployments and actually implement it yourself, and kind of step back and say, take your IP. Take your value add, put it on the platform, and then manage everything, every aspect about it.
So there, it launched my website.
Yeah, as you can see here, it actually deployed. So it said, hey, there's a new target here. Let's go ahead and pull it down using the update framework signed manifest, and then using the signed Docker image that was produced in the build. So then what it did, it's the same application, but just different configuration, and it updated this display, near real time. Now, what's really neat about this is all I had to do is change one string, and I was able to change the website in an in-field deployment. This is running on battery over Wi-Fi. So if you had a digital signage display, in a mall or at a conference, you could easily update the content on there just by simply pushing to your FoundriesFactory, right? You didn't have to go and press levers down and do all of this different stuff to get it to go out. It just kind of did it for you. We also offer, on the enterprise tier, a way to actually test these devices. With our CI system. So you can have real hardware devices connected to your factory, run tests on them, and if those tests pass, you can promote these images maybe to the devices in the field or a set of canary devices. So we have staged deployments. So as you push this code and develop it, you don't necessarily have to take it to production. You can have small test farms where you can validate that the use case still properly works.
So how does the IoT market work? Because IoT is a trillion devices,
Yes.
right? That's what Masa is saying. Trillions of ARM chips are going to be everywhere. Until now, IoT devices have been very fragmented, poorly updated, a security nightmare, hacked, all this.
Yeah, well, and typically, embedded, right, which is a subset of IoT, you've kind of taken a vendor kernel and you've done what you had to do, and you made the product work and you got it out the door. I worked at Honeywell for a long time, and we shipped products, and we had to sustain our products for 20 years, sometimes even longer than that. So, that mindset's been in the industry, but usually only an industrial customer. So these consumer IoT devices really haven't had a whole lot of time to develop a strategy around that. But with the hardware level exploits that are out there now, every IoT device maker should be thinking about their security story, and not only just how to keep your device secure, not only how to update it, but what's your software story behind what you're updating. Are you on a forked piece of software that's not supported by the upstream maintainers? Because if you are, you need to change that, because you're going to have all these security patches flowing in, and you need to decide whether you need to take them or not. The worst thing you can do is get yourself out on a fork with nowhere to go, and so you have to invest your company's capital back into making sure that platform is secure and has the latest updates, and that's a lot of work. So the idea is FoundriesFactory gives you the tooling that you need to maintain this, manage it, and build your updates and stage how they get deployed. So kind of taking the complexity out of how to do all of that, but then using upstream open source software to accomplish it.
So what do you mean by factory?
Yeah, so factory is like an acronym for our product, so we could try to link people's brains to what happens. So when you're building a software product like an embedded device, you kind of have a build system, you have a way of testing it, and then ideally, hopefully, you have a way of updating it over the air incrementally. But a lot of times you don't have all those pieces, and you kind of have to go and look and say, well, what's out here, and kind of do some trade-offs. So we kind of gone through that and said, what are the software components that people are going to need, like OS tree, the update framework, you've got Yocto and Open Embedded, and keeping everything minimal, take these software pieces, assemble a recipe, and then give you services that allow you to keep them up to date, right? And to build and customize your product. That is a factory, right? Something that you create something with, and that's why we've used that naming convention. We just think it resonates with people. They understand, products get built in a factory, and that's what we're trying to accomplish here with FoundriesFactory, is that you build your software product with us.
Because what makes a really good IoT device is something different, something new, something proprietary that you add on to open source.
Yeah, and it doesn't
right?
necessarily have to be proprietary per se, but a lot of it is, and a lot of it competitive advantages. Making like the voice recognition faster, right? And a lot of times those libraries are proprietary. So we want to enable a system that allows you to deliver your proprietary, application or value add, but then also being able to leverage all of the open source goodness that comes along with it. And that is a security story in itself, right? Being able to use open source in an effective way, but still being able to provide your own IP on top of it is really the model that we're going after. And we have customers that are doing this today who have been, very successful with it. And we're just trying to make sure that this model, could bring as many of these people making IoT devices in, and we're not, focusing on one use case over another one. So keeping everything generic and keeping the platform flexible.
So is it kind of like an app on top of embedded Linux? Is that what a great IoT device is?
Well, no, because it could be, you need to do your own driver, right? And your drivers themselves potentially could have some IP in them, right? And so you need to build that in the platform. Now, if you link it against the kernel, you're going to have to provide it. There's no way around that. And that's another thing that FoundriesFactory gives you, is it does compliance for you. So any GPL sources that are used in the build, you'll get a manifest saying, here's all the projects that are GPL licensed, and here's all the tarballs for source. So it helps you a little bit with, maybe your legal department if you're building a product, where you say, hey, this is all the open source software we need to comply with. Here's a list of it, and then here are the source tarballs that you need to provide to the public to be in compliance. So, that's one aspect of using the open source and trying to make it easier with the FoundriesFactory for you to be in compliance. And, it's one step in product development that you don't have to really think about anymore because it's done for you. So adding convenient features like this to help product developers is really what we're aiming the FoundriesFactory towards.
It's a little bit in the same vein or idea as AWS and Google Cloud, where they are taking the whole data center aspect out of startups. They don't need to worry too much about that. Whereas here, they don't need to worry about security updates and
tooling. Yeah, you got to build all that as a startup, right? And not only just security, but the processes in which you develop the software and the signing and all of that's kind of taken care of it, for you. You get to keep your offline keys, so you actually have control over, rotating the keys if necessary in the factory, even though we host it. So, I think that's an interesting. Point that you're making there is that, this stuff has to be secure and it has to be updatable. So that's what the FoundriesFactory offers you.
And so what's the status? You have some adoption, and what's the latest? There's been some news with Foundries, right, recently?
So we did a Toradex webinar. We worked closely with Toradex. Their version of the Linux microplatform, which is called Horizon, is direct ancestry to the Linux microplatform. So they kind of customize that for their hardware. Now that's a perfect example of a FoundriesFactory, right? But you want to take our base operating system, the Linux microplatform, and then add your custom SoC code to it, and provide a similar experience to what we get with the Linux microplatform. Well, that's a perfect example of how a factory would work. You bring that code in, you can even make it public, so anybody that uses Horizon, can connect to that FoundriesFactory. And then we have a Docker app store that's user definable, so you can define what Docker apps you want to have as demos, and then customers using that can just try the demos out and evaluate. And then if they want to make a product based on Horizon, they can start a FoundriesFactory and customize it to their own needs.
So what kind of examples do you have so far? What kind of projects are you working on, or demos?
Demos, we're trying to stay away from demos. We're really trying to stay focused on customer needs. And so what we're seeing a lot of uptake in is robotics. And particularly, autonomous robots seem to already use ROS frameworks and things like that. And they typically, those developers of the robotics products typically are pretty up to speed with containers, and maybe they aren't as skilled in embedded, or they would have two teams where, there's a platform team that really knows the embedded side, and then there's a robotics team that kind of knows how to do robotics. And I think FoundriesFactory helps them out there because since the platform and the application codes are separated, it's a lot easier to have different velocities when developing the platform code versus the application code, and then you can bring them together. And basically, there's usually not a whole lot of dependencies on either one. So you can have the app team move at the speed of light, or the platform team move at the speed of light, or both at the same time. It doesn't really matter. And then they can assemble a working product together, where either piece is owned by a different division inside of a company, and they can be updated independently or together in lockstep if needed.
And so you have robotics. What other kind of update do you have?
So wireless sensors are a big one. Being able to have a smart gateway that can connect to wireless sensors is another big one. We see Wi-Fi security as another interesting one. So devices that actually sit on your wireless network and monitor what's happening, and if there's any unauthorized access, or there's an exploited machine that's going out to the internet and going to places that you wouldn't expect it to go. It kind of flags that and brings it in. So actually, security devices there, automotive market as well. Anything that needs.
What part of the automotive?
Usually, so you can do infotainment, right? I mean, that's a big one. That's not safety critical. Now, if you start getting into the electronic control units, you need to have safety critical operating system and stuff like that. And that's really kind of where we've stepped back and said, that's not really where we are. So infotainment in cars is another area that we see. But any real connected product, I mean, that's the best part about the Linux microplatform, is that it doesn't have to be one thing or a series of things. It can be anything you want. If you can put it in a container, if you can build it into the kernel, if you can build it into the user space, it can be whatever you need it to be. But you have a consistent software story, it's updatable, and it has security built into the platform.
And what about so you're doing lots of Linux, embedded Linux. Yep. How about the Zephyr?
So Zephyr's interesting. With bare metal RTOSes, everybody likes to roll their own. It's a very fragmented industry still. I think Zephyr's doing a great job to make that better. However, we are kind of rethinking how we position a product for Zephyr. Obviously we're open to working with people and customers if they have a need to, but what we're finding is a lot of times the Linux gateway is the piece that they're missing, and that they have already developed an RTOS that can talk standard protocols, and they just need a way to route that to the internet, and the Linux microplatform is a perfect way to do that. So that's what we've been focusing on lately, until we have a little clear picture of how we're going to solve the fragmentation with the RTOSes. We're just going to have to wait and see.
Linux is king a little bit, right? There's a lot of people just wanting to use Linux. That's why you're in green.
Yeah, well, of course, maybe. Right?
So Linux, you're mastering the Linux. Linaro is all about Linux and ARM.
Yep. Mm-hmm.
And Zephyr is also a possibility. But how about, it's supported, probably. But how about, how much is possible to be done right here?
With the RTOS?
With Linux.
Oh, I mean, the sky's the limit. In fact, we're starting to see, there's this new thing out there. It's like a crossover MCU, right? Which is almost fast enough to be a Linux class processor, but runs an RTOS, right? And we're starting to see the low end of Linux processors come down too. So there's just going to be this interesting area where if you have to maintain a product for 20 years and you've rolled your own RTOS, or you're using a forked version of an RTOS, does it make sense for you to maintain that using an MCU, or would it be better if you run Linux on an application processor and then you have a software story because you're running Linux? That's going to get constant updates. It's if you use the FoundriesFactory, it's a little easier to manage how those software updates flow down to your devices. I think it's more of a generic, general purpose solution. Now, if you have a use case where, you have tight constraints, they have to be real time. Linux does have patch set to enable those use cases. But if you start talking about using 1 meg system RAM or under that, that's where the RTOSes really shine. But the BOM costs are kind of converging, on the low end of the Linux devices, and then the high end of the MCUs kind of converging together. So it'll be interesting space to see what happens in the next few years.
So you're very, Toradex is just down there in Seattle, yep, where I was filming. So you partner with them. How about what chipsets are you supporting so far? Is it a lot of NXP? Or?
Yeah, a lot of NXP. They're mostly an NXP shop down there. What we're really interested in is making sure all the hardware security features, like the HAB, are functional in the Linux microplatform, so we can securely store, any keys or certificates that we generate on a user's behalf. And the idea is, with a Raspberry Pi 3, there's only so much you can do to secure that platform. And a lot of people have it, and so we support it, but it's not a good reference on how to do security properly. So we're actually leveraging the IMX6 as our first reference platform for a fully secure design. That means you obviously have secure boot, and then you also have the actualizer light client, the client that does the tough updates using the secure storage area to store the TLS keys that it uses to provision with. So we want to show an out-of-the-box secure solution on their hardware. IMX8, as it gains more upstream support, is another target that we have in mind. Obviously, that's a newer 64-bit variant with a lot of cool features. So we're excited to get our hands on that and do a reference as well on that.
And the new chipsets are going to have hardware security and machine learning, maybe a lot of new things.
Yeah, we're seeing a lot of FPGAs getting put onto chips, and for that specific use case. So they can, you can load a bit stream, and you can do ML or AI routines with that, and then having all the sensor data being connected to a gateway and having an FPGA that can actually process it on the edge there and send it off. I mean, those are all interesting concepts that we're working with customers on.